This segment covers list comprehensions, which are a very powerful mechanism for defining lists from other lists. The model is to generate and transform elements. So let's look at this first example. It says, you can see it's a list, it has square brackets outside, and it says 2 times x. And if we read the vertical bar as where x comes from the list 2, 3, 7. So the idea is we're generating elements from that list 2, 3, 7, and in the result we're putting in 2 times x. So x runs through the elements of the list 2, 3, 7, and 2 times x is included in the result. So what we get is the list 4, 6, 14. Because 4 is 2 times 2, 6 is 2 times 3, and 14 is 2 times 7. So the generate here is x coming from the elements of the list 2, 3, 7, and the transformation is got because we're doing something to those elements. We're multiplying each of them by 2. So this is called, and this leftward arrow is meant to look a bit like x is an element of in the notation you'd see in set theory. A Greek E. So that's the reason. And you can see it also, it's an arrow saying take elements X from that list. So you can generate and transform, but you can also test elements. So we can say take the X from 2, 3, 7, but only the X that are smaller than 7. So we have the generator, X comes from 2, 3, 7, comma, and then a test, x less than 7. So what we'd expect to get from this is the list 4 and 6, because it's taken x to be 2, that gives us 4, x to be 3, that gives us 6, but when x being 7 is a possibility, that's ruled out by that test. So we have a general model of generate, transform, and test. Let's look at some more examples of that. We can use patterns on the left-hand side of that leftward facing arrow to extract parts of the matched elements. So here we say, let's take pairs m, n from this list of pairs 2, 3, 2, 1, and 7, 8. And what we do with them is we add the two halves together. So we get m plus n, where m is 2 and n is 3, so we get 5. We then get 3 from the pair 2, 1, and then we get 15 from the pair 7, 8. So we can use patterns to extract parts, which we then transform in different ways. We can use multiple generators. So here what we're doing is we make a choice of x, and then with that choice we run through all the options for y. So, and we'll see that gives us a list of pairs. You can see the order of the list of pairs tells us how things are being selected. So as you can see, we get the pair 2, 4, then we get 2, 3, and then we get 2, 5, because we've first of all chosen x to be 2. And with that choice, we then look at generate everything from the next generator. So we get y runs through 4 and 3 and 5. And then we make another choice for x, and then y runs through 4 and 3 and 5 again. And this is, you might call this the product of the two lists, because we're taking every possible combination of an element from the first list and an element from the second. So, and that shows you how the multiple generators are used. X first, a choice for x, and then run through y. And if there was a z for each choice of y, you'd run through all choices of z, and so on. You could also, if we've got this a list of shapes which have circles in there and rectangles as well, we can say, oh, just take the circles from that list of shapes by putting a circle pattern on the left-hand side of the leftward facing arrow. And for a circle, return its area. And you can see if we apply that to this list here, which has the two circles, circle 2.1 and circle 4.7, we get the result 13.85 and 69.39, which are the areas of those two circles. And we can use these list comprehensions to define functions. Here's a nice function that takes an integer and returns the list of its divisors. So those are the numbers which go into divide that number without a remainder. And what does this say? To give the divisors of n, what do? Well, we generate the numbers from 1 up to n, that's the numbers m, and then we check, is the remainder when we divide m into n 0? That's what mod means, modulus. That gives you the remainder when m is divided into n. So that will give us, that function will give us a list of the divisors. It gives us the numbers m that meet that condition. So they're the numbers m that go into n a whole number of times. And then we can test whether a number is prime by saying n is prime if and only if the divisors of n equals the list just 1 and n. The only divisors there are the number itself and 1. So that's a way of describing using a list comprehension there, generate and test to give us the list of all the divisors, and then we check for primality. It's a prime if the only divisors are 1 and the number itself. Another example is a test for being a perfect number. A perfect number is one where the sum of the divisors smaller than it add up to the number itself. So the divisors of 6 are 1, 2, 3 and 6. And if you add 1 and 2 and 3, you get the answer 6. But if you add all the divisors, it's 1 plus 2 plus 3 plus 6, which is 12. So the test for being a perfect number is that the sum of the divisors is equal to twice the number itself. And then we can, if we want to find all the perfect numbers below 10,000, we can build this list here. The list at the bottom says, give me all the n's where n comes from 1 to 10,000, and the test is that that n is perfect. And you can see, in fact, there are only 4 numbers below 10,000 that are perfect. There's 6 and 28 and 496 and 8,128. It's fairly easy to check the first 2. I let you do that. I take, you can check that it works for 496 by actually looking at the divisors and adding them up by hand, should you wish to. But this gives us a nice way of generating values, testing them perhaps. Are they perfect? Do they divide a number without leaving a remainder? Or transforming them perhaps, or a combination of those. And we will see, if you want to look in the section 5.7 of the book, there's a whole section there devoted to designing a simple library database which uses list comprehensions to look up various kinds of data, as well as how you might want to do update and so on. So if you want a longer example, that section of the book will cover it. But what we'll do next is look at the list API in general, but that's for the next blog.